Welcome to the CATIA 3D experience, where we will develop the way to support new engineering challenges in a social, instinctive, and inclusive way. Through a conceptual opening doors study, you will understand how the social innovation process is valuable from the concept to the virtual multidiscipline simulation. Social collaboration. So here, the first point is to show how important it is to have people connected inside and outside a company, to express and get their ideas in an innovative way. Here we are seeing the 3D dashboard of the 3D experience, and we have, for example, the 3D play aspect of the global project, where I am able to visualize the way things are running. On the right side, you can see the different communities which I am working on and where I'm connected. Here, I'm making a dedicated focus with the inspired funnel on the top, and people are exchanging different ideas. For example, here we see that someone has an idea to connect the Kruger flap example of wing from an airplane in the same spirit of the opening door system of the car. And by the way, the car has been inspired from the aeronautics design. On the left, I retrieve where all the 3D space data has been stored in the system, and I am able rapidly to filter them with the capacity to access the right information. Here, I'm looking at the opening door system tag, and I can check, for example, which door we are talking about, and what are the systems I need to create on top of this design, which has been frozen by the Design Study Office. From this, on the top of the compass, we have the different roles access. Here, for example, I want to check the definition of the tasks and requirement which have been created to realize this opening door system. I'm able to rapidly validate and check the different tasks to be done. And what are the levels of requirements that I need to run through to respect the definition of what has been asked? I'm also able to check the applications and roles I need to validate to make the job. Here, I have selected the mechanism simulation to check. This is a role I need to import. And I can also build my most useful applications in favorites. 3D conceptual design. So let's start with the 2D conceptual study here. We have in the CATIA 3D experience environment this 2D layout for 3D design that helps designers to start a first 2D sketch but in a 3D spirit. So you see that we are able to share different positions of the same conceptual idea of doing this mechanism in a 2D way with different points of view, but trying also to start to do the manipulation and the simulation of the 2D sketch here. So I'm able rapidly to validate that. But these are only 2D sketches. We can directly switch to my 3D view and start building the complete mechanism and part design through this 2D sketch early study. So this is exactly what they will start to do. This is where you are using, for example, CATIA Natural Shape application, where from this sketch they are directly manipulating a shape from the profile, pulling the thickness of this part, and they will drive all the design of the mechanism based on this CATIA natural shape. This concept phase rapidly gives them the capacity to propose some alternatives without entering in detailed design. But all of that, as you can see, is directly designed in the context of the complete car program definition. So they were able here to manipulate, create all single parts, and create this mechanism. Based on this mechanism, now they want to simulate the first level of kinematics. So for this simulation, they just have to select the play button of the compass where all of the constraints of the assembly are directly reused for simulating the first level of kinematics movement. So here we are talking about mechanical simulation. It doesn't include how the speed of the system will go, it just shows you how the mechanism is behaving. It's already an important stage of the project because here they are trying to see how it respects the interference shaking, the clash, or the movement itself. So all of that have been rapidly validated with the interaction of different profiles of people coming from the original idea to the design of the conceptual phase. How will the project manager connect to this? The project manager wants to check and validate what has been done. To simplify that, he gets access to the platform through, for example, this mobile device with a touch screen where he is able to replay the 3D kinematics behavior, but also the definition of the sketch and different values of the conceptual definition. He is able to directly reuse what people published and shared to let him make the right decision. The 3D Experience platform sustains all people's profiles to be part of the project milestone. Mechatronics evaluation. So now let's move on with the mechatronics role. The mechatronics guy is there now to validate the real behavior of the system, which includes the electrical motor that will have to sustain the movement with the rules of the behavior from electronics, electrical wire, and the mechanism behavior. So here we can see that the guy is really creating this new electrical engine connected to this mechanism, and he will simulate it. Here he retrieves the language of Modelica, describing the mechatronics definition of the system. He will now play the experience of the door opening to check whether with this engine he can really sustain the way the door has to be opened. We can see on the right that this diagram is showing that there is a peak of the torque requested to support the conditions, which is too high, so he will have to change things to reduce it. You cannot simulate and find that there is a problem between electrical and mechanical without combining these roles. This is where the value is, meaning that with mechatronics and mechanical systems, we have been able to support the complete process and validate it with different roles. Electrical harness design. In a modern car, the wire harness is one of the key and most expensive subsystems that connects all electronic and electrical devices. This harness contains about 2 to 4 kilometers of wires, with many connectors, splices, and supports. Since it is in almost every part of the car, a detailed design inside the 3D digital mock-up is essential to improve quality, reduce costs, and speed up design time. CATIA not only provides the applications to do the 3D design like you see here, but it covers the end-to-end integrated process, from schematic design to the creation of manufacturing documents in a complete, synchronized way. Body in white. In the continuity of designing the door from a body-in-white standpoint, hydroformed sheet metal can manage complex sheet metal parts. You can create designs rapidly and efficiently, using a specialized set of features and easily reuse company know-how. It allows you to add manufacturing constraints at a design level and perform concurrent engineering between the unfolded and folded part representation. Fastener design engineering. Let's move on with the chassis of the car. With the fastener designer role, you can design fasteners ranging from simple to sophisticated easily and with scalability. You can reuse existing assets and automate repetitive tasks to improve design time and productivity, and also analyze design impact by easily navigating among fasteners and fastened parts with a simple but powerful review. Composites braiding. Now let's take a look at the new composites braiding solution. It provides advanced braiding fiber simulation to enable designers to visualize fiber paths on complex surfaces and optimize machine parameters to achieve the desired fiber orientations. The solution performs accurate mandrel generation to create correct fiber volume fractions to minimize mass and provides a consistent virtual process chain that automates the planning of existing manual braiding processes. It also provides a seamless link to calculation and manufacturing tools, providing an integrated and efficient process. We have been able to show how CATIA 3D Experience supports all users' roles in a social, instinctive, and inclusive way.